Alright guys, so next up we're looking at 9.3, which is going on into more of our 3D figure stuff. And today what we're going to be talking about is the volume of prisms and cylinders. So the first thing we're going to look at is specifically what made up something called volume. And this guy named Cavalieri came up with this principle. So Cavalieri's principle says if two space figures have the same height, so basically like if you have two rectangular prisms that have the same height and the same cross-sectional area at every level, so that means every single level within those two shapes, if they have the same area on those cross-sections, then they have the same volume. So this is what brings up the whole volume and volume of a prism and a volume of cylinder. So basically, in order for us to find the volume of these two, literally all we have to do to find the volume of a prism is equal to B times H. And what I want y'all to make sure y'all remember is capital B always stands for the area of the base. That's why I'm writing it really big. It's going to be the area of the base. And so basically for both prism and cylinder we're doing the same thing. So on a prism we're going to find the area of the base and multiply it times the height. Then for a cylinder we have a circle as the base. So we're going to find the area of the circle, then multiply it times the height. Okay? So now let's go and look at some vocabulary down here. So for our first definition here is going to be volume. So volume is the space that the figure occupies. For volumes, your units are always in cubed units. So basically, if you have a Coke can, all the area inside that Coke can is called the volume. If you have a cup, all the area inside that cup is the volume. So everything inside of an object is going to be your volume. Okay, and for your last definition, you have something called a composite figure, which by definition is a three-dimensional figure that is a combination of two or more simpler figures. So basically speaking, if I had a square, or if I had a cube and a rectangle and I put those together, that would make a composite figure. So I'd have to break those up and find the area of those two in order to find it. So again, a composite figure is basically made up of multiple ones. So let's go ahead and switch over, and we're just going to do some examples to get you guys working with volume. Alright guys, so here goes your first example. So right now we need to find the volume of this cylinder. So if you're trying to find the volume of any right prism, right cylinder, whatever it is, you're always going to be doing volume equals the area of the base times the height. So the only thing that changes whenever you're doing with a cylinder is you have a circle. So the area of the base, you have to find the area of the circle, which is the base. So the capital B is going to turn into pi r squared, because that is the area of the base, which is the circle. Then I'm going to multiply it times the height of your cylinder here. So literally all I have to do is plug in the radius, plug in the height, multiply it out, and I get my volume here. So let's go ahead and do this. So right now my diameter all the way across is 16. So to find my radius, I have to divide that by 2, which is going to be 8. So it's going to be pi times 8 squared, multiplied times the height, which is going to be 9. So remember, if I wanted to find my answer in terms of pi, I would leave the pi out, multiply everything, and get my answer, but I'm not. I'm just getting the regular answer. So if I multiplied all this out to find my answer, I would get 1,809.56 feet cubed. Because remember, cubed is what volume is always measured in. So that means there is 1,809 cubes, 1 by 1 foot cubes that could fit inside of this cylinder there, ladies and gentlemen. Alright guys, so let's look at example number 2. So example number 2 now, we have a triangular prism and we need to find the volume of it. So with this triangular prism, we know the volume is going to be the area of the base times the height. So we need to analyze just the base at first. So look at the base, I have a triangle as my base. So to find the area of a triangle, I'm going to replace the capital B with 1/2 BH, which is going to be the area of the triangle. Then I'm going to multiply that by the height of my prism here, which is H. Okay? So the first thing I need to look at here is on this triangle, I have a base, but I don't have a height. So since this is a right triangle, I can use Pythagorean theorem to find the height. So I know since this is 29, this hypotenuse would be 29. So if I ended up tagging this in, I know a squared plus b squared equals c squared. So I would do a squared plus 20 squared equals c squared, or c would be 29, okay? And then I would end up squaring these and subtracting them, and I would end up getting a is equal to 21. So that means my height is going to be 21 meters here if I ended up finding that. So let's go and plug everything in. So right now, just looking at my triangle, my base is 20, my height is 21. So this formula is going to be 1/2 the base, which is 20, multiplied by the height, which is 21. Then I'm going to multiply by the height of my prism, which is in between the two bases, which is going to be 40. So if I multiplied all of that out, it is going to come to a grand total of 8,400 meters cubed. So remember, cubed is going to be volume, what it's going to be measured in every single time. So that means if I was to have this triangular prism in the real world, that there would be 8,400 1 meter by 1 meter cubes that could fit inside this space. Alright guys, so lastly on example number 3, this is the third and final example, we have something called a composite figure. So you have to remember a composite figure is basically two or more figures that are combined together, and we need to end up cutting these into separate pieces to help me to figure out the puzzle to basically figure out my volume. So what I'm going to do is I'm going to find a cutoff point to where I can make 2 or more shapes that I know I can find the volume of to help me to find the volume of the composite figure. So the way I looked at this, and there's other ways you can do this, and you can figure that out if you want to, but the way I did this is I went ahead and I cut across into this section right here, which if I cut it right here, I also have to cut it going down here. So basically I cut off 2 triangular or rectangular cubes, and I cut off 2 rectangular cubes here as well. So basically what I'm going to do is I'm going to take this information, and I'm going to do, I forgot to draw this thing right here, okay? So what I'm going to do is I'm going to find the volume of this guy right here, I'm going to find the volume of this guy right here, I'm going to find the volume of this guy up top, and I'm going to end up adding those together to make my composite figure to find the volume. So basically I'm going to do 3 different volume formulas. So I have a rectangular prism, a rectangular prism, and a rectangular prism. So I'm going to do volume equals base times height, volume equals base times height, and volume equals the area of the base times the height. So what I'm going to do is I'm going to treat these spaces right here that are up front, I'm going to treat those as my bases, because I know on the back side they're this exact same thing. So let's go and look at this. So let's look at this shape right here. So right now, this face right here, on this base, I have a base of 4 and a height of 6. So right now, the area of my base is going to be 4 times 6. So that's the area of my base. So I know this base is going to be the same thing on the back side, and the distance between those two bases is 25. I see it up here in the top. So this is going to be 25 centimeters. So that means the height of this is going to be 25. So I know this rectangular prism and this rectangular prism are going to be the same thing. So I'm just going to copy that formula right here. So 4 times 6 times 25. So now I need to find the volume of this guy up here, and I'm going to treat this again as my base, which is my rectangular face. So right now, if you look here, this is going to be 6 centimeters. This whole side is 10 centimeters. So that means this little section right here is going to be 4 centimeters right there. And I'm just going to erase this guy so we can see that better. Okay? So here we go. So the area of my base is a rectangle, so I'm going to do base times height. So base times height is going to be 14 times 4. And then the height of my prism is going to be 25. So I'm going to multiply times 25. So now, ladies and gentlemen, all I'm going to do is I'm going to multiply all these out and then add them together. It's going to give me my total volume. So right now, if I did 4 times 6 times 25, that's going to give me 600. 4 times 6 times 25 is going to give you 600. Then 14 times 4 times 25 is going to give you a total of 1,400. Then if I added all those together, the total volume for my composite figure is going to be 2,600 centimeters cubed. So what that means is inside this composite figure, 2,600 1 by 1 cubes, centimeters, can go inside this composite figure here. So ladies and gentlemen, this is a little tricky, but you can figure out how to cut it and how to find your volume here.